Hi, I'm Jeremy, and I'm a head of maths at a school in London, and I'm also a GCSE Examiner. And today we're going to run through some skills on fractions. And what I'd like from you is, if you've got any questions at all, please use the Show Q&A button at the top of your screen. So it's two speech bubbles with a question mark in it. And that's going to help you guys ask me the questions. And we've got a producer, Paul, who's going to be able to run through those questions and ask me on your behalf. I'm planning on going through the questions in the eyes of a student. So I'm going to talk you through what I'm thinking as I approach each question. We're starting with basic skills, and hopefully you've had a chance to look at the homework that was sent out to you. So we're starting with the basic skills, the kind of bare bones of fractions, if you like, before moving on to the exam style questions. And again, I'm going to show you where the marks are available. There's some very tricky ones in there towards the end, especially. The final question itself is a higher only question. But everything else could be found on the foundation or higher specs. It's a crossover topic that's really useful. And fractions obviously underpins a lot in maths. We have algebraic fractions going right through to the top end of GCSE and through to A level. And having that good understanding is really, really crucial. Okay, so without further ado, and just remember, two speech bubbles with a question mark in the middle. Ask any questions you want about the maths or about GCSE maths in general, and I'll be happy to answer them throughout this session. So hopefully you can see my screen, and if not, I will be told, I'm sure. And we're going to approach these questions, as I said, starting with the skills-based questions, moving on to more problem-solving, more exam-style questions. So here we have 2 4/9, and we want to write it as an improper fraction. This is also known as a top-heavy fraction, where the numerator is bigger than the denominator. Okay, so in order to do that, 2 4/9. I always write the question again. I mean, not obviously a worded question, but I always like to write, for example, here the mixed number again. It just helps me settle myself for the question. It's always great to start writing something. It gives you a starting point. Now, in order to convert 2 4/9 into an improper fraction, we need to multiply our whole number, which is 2, by our denominator, which is 9, and then we add our numerator to that. So we're going to do 2 times 9, and then we're going to add our numerator to that afterwards. The denominator in this process will not change. Now, converting mixed numbers to improper fractions is crucial. Pen is bugging out a little bit there. It's crucial when doing adding and subtracting mixed numbers. It's crucial when doing multiplying and dividing mixed numbers, and sort of these exam questions that we have. Do bear with me. And is just protesting a little bit. Let's try that one more time. There we go. Okay. So 2 times 9 plus 4. Now, BIDMAS means that we're going to do the multiplication first anyway, but it's also written at the front, so maybe people would naturally think to do that. So 2 times 9 is 18, plus the 4 is 22. 22 over 9. And that is absolutely the right answer. We do not need to do anything more with that. The only thing we would need to consider is potentially we can potentially look to simplify, but in this instance we can't. There's no common factors between 22 and 9. Okay, here we've got 5/6 of 48. Now that is the same. The of is actually a multiplication. When we talk about fractions and we talk about 5/6 of 48, it means 5/6 times 48. Okay, now there's a few ways in which we can do this. Some people like to consider using converting 48 into a fraction, and the way you convert whole numbers into fractions would be to do this: 48 over 1, and then multiplying fractions you multiply across. Now that wouldn't be the approach I would take for a question like this, but it would work. So if you've done that in your homework, that's absolutely fine, and well done for getting it right. For me, when I'm multiplying a whole number by a fraction, the way I like to think of it is I divide the whole number by the denominator. The denominator is always a division. Okay, so divide the whole number by the denominator and then multiply by the numerator. So I would rearrange this question, and it's exactly the same. This is exactly the same calculation being performed. I'd do 48 divided by 6, and then I'd multiply it by 5. Okay, 48 divides by 6 quite nicely. 48 divided by 6 is 8. And then I'm going to multiply that by 5, which is, of course, 40. So 5/6 of 48 is 40. Okay, both of these questions were 1-mark questions, so you're not getting anything unless you've got the answer for the questions. So we would have got 1 mark for 22/9, and we would have got 1 mark for 40. Obviously, because it's 1 mark, you don't actually have to show the working out that I've shown. The answer is the important thing. I'm just showing you the process that's going on, potentially even in my head, because I can do 48 divided by 6 is 8, times by 5, 40. I can do that in my head, but if you're not sure if it's difficult numbers, then you might want to focus on writing it down first. Okay, so we've done the first 2 skills check questions. Let's move on to the next one. What is incredibly common as a mistake with this question is to just do 2/5 of 26. So let's just quickly have a look at it. If 2/5 of a number is 26, what is the original number? So we're actually looking at working backwards here. We had a number, whatever it was, we found 2/5 of it and got 26. I want to know what the original number was. So that is not doing 2/5 of 26. We're not going to do that. That's not what the question's asking. We did 2/5 of something and got 26. So let's have a little look at the best way to answer this. If you're not sure, a bar diagram can be incredibly useful to help you think about this. Okay, 5/5, 5 out of 5, that would be the whole number. The whole number would be 5 out of 5. So I draw myself a bar. It doesn't have to be perfect. And I'm going to split it into 5 equal sections. There's 1, 2, 3, 4, 5. You can see that's definitely not perfect, but it'll help me when I'm thinking about how to process this question. Okay, this 5/5, all these 5 bars here together, they are my original number. They add up to it. Now, 2/5 of that, this is 2/5. My pen will let me write. All right, it's a bit technical for the computer here. My curly bracket is it's not getting on with it. Okay, anyway, let's just do a normal bracket then. These 2 squares here, they're shaded, they are 2/5. Okay, and they are also representing 26. 2/5 of my number is 26. Okay, so if I want to know what 1/5 is, I'm going to half that. Each of these bars is worth 26 divided by 2. It's 13. Okay, so I've got 13 here, I've got 13 here, and I can think about all of my bars as being 13, so I'm then able to find the total amount. So that's obviously 5 lots of 13. 5 times 13 is equal to 65. That would be the answer that we were after. Okay, 2 marks available here. 1 mark for breaking it down and finding 1/5. Now there's lots of ways, and you might have done it a different way. There's one thing I'd like to stress is there's no right or wrong way to do fractions if you're getting to the right solution. Okay, there are so many different ways of viewing things, pictorially, algebraically, And you might have a method that works for you. And if you do have a method that works for you, then that method works and you can stick to it. Of course you can. So 1 mark for identifying 1/5 as being 13. And then 1 mark for identifying that 5/5, the whole, is 65. You get your answer mark. Remember, your answer mark is only really ever worth 1 mark. So you need to do the working out and you need to show that and demonstrate it to get those working out marks. Okay, so again, just focusing on skills at the moment, what we're being asked to do is work out 2 and 8/15 minus 1 and 1/3. We've also been asked to give our answer as a mixed number and in its simplest form. Now, that doesn't mean you always have to simplify, because sometimes you still can't, and the examiner doesn't want to give any clues away, so they're not going to tell you whether it simplifies or not. But I know that the form I leave it in must be in its mixed number, and if possible, it must be simplified. First thing we need to do, I always, as I said to you before, I always write out the question. 2 and 8/15 minus 1 and 1/3. It helps me process what's going on. It helps me process what's going on and allows me to kind of set myself and ground myself for the rest of the question. Okay, so now what I'm going to do is I'm going to convert this mixed number into an improper fraction. So, like before, I'm not going to write it out this time. I showed you the working out in question 1. Now we're going to, but it's the same idea. So 2 times 15 plus 8. 2 times 15 is 30, plus 8 is 38. 38 over 15. And I'm going to subtract from that 1 and 1/3, which 1 times 3 plus on the numerator, which is 1. 1 times 3 plus 1 is 4. So it's 4 over 3. The denominator never changes, does it, when we're converting into improper fractions? Or going in the other way, the denominator would also stay the same, which you're about to see in a second. So anyway, let's get on with this. We're going to be subtracting fractions now. That's another skill that we've not looked at yet. And hopefully you remember that to subtract fractions, you have to have the denominator the same. That means I need to change one or both of my denominators. In this question, the easiest thing to do would be to change the denominator on the right, to change that 3, because 15 is a common multiple with 3, and if I just times my 3 by 5, I'll turn it into a 15. Of course, you do the same on the top as you would the bottom. So we times both by 5. So I don't have to change the first fraction because it's already in 15s. I'll keep that the same. Then I'm going to subtract my newly, it's an equivalent fraction, so it's actually exactly the same fraction in terms of its meaning and its value, but it looks like a new fraction, and that's 20 over 15. 4 times 5 is 20, 3 times 5 is 15. Okay, so we do our subtraction. 38 subtract 20 is 18. Now, some people might think they might want to subtract their denominators. In my experience, generally students, because you've been doing this since primary school, you don't often make misconceptions with adding and subtracting. You do remember that the denominators don't change. That's just in my experience, it's what I've noticed. So we subtract our numerators, which is 18, but the denominator stays the same. Okay, so that's that. That's great. Now, there's two things we can do here, actually. We can simplify it because there is a common factor between 18 and 15, and we can turn it into a mixed number. It doesn't matter what you do first. For me, I'm going to simplify it first because when I'm turning it into a mixed number, I'll be working with smaller numbers, and I prefer that. But it doesn't matter what you do. There is no preference for an examiner, let's say. So 18 out of 15 can, as I said, be divided by a number. The numerator and the denominator can be divided by the same number. They can both be divided by 3. You always want to try and get the biggest number to go into them. We call that, I'm sure you remember, the highest common factor. In this case, 3 is the highest common factor. So 18 divided by 3 is 6, 15 divided by 3 is 5, and we've got 6 over 5. Now we need to go back into mixed number form. So we've got it in simplest form, now we need to have it in mixed number form. 6 over 5 in mixed number form, well, how many 5s go into 6? 1. 5 times table, 5, 10, 15. Only 1 5 goes into 6. And there is a remainder of 1. And the denominator does not change. Remember what I said, going from improper to mixed and the other way, the denominator is always fixed, isn't it? So it's 1 and 1/5. That's what we're after. Now, this is a 3-mark question. Where are we bagging those marks? First mark for the conversion at this end here. Second mark for the process of moving over to having the same denominator and subtracting, so getting towards our 18 over 15. You can make calculation errors though and still get that mark. Okay, and then the final mark comes from actually having it in the exact form we need to, so simplifying it and putting it in a mixed number. You need to have it in this form here for that final mark. Nothing else will do. Okay, you can get 2 marks. If you ended up with 6/5, that's great, but that's only 2 marks out of the 3. Okay, so we're getting there. Division. Now I picked a dividing by fractions question to do for our skills check, question 5, because dividing fractions weirdly combines both the dividing of fractions, that's in the question, but the skill we use is actually to multiply. So that's why I picked it, because then you're revising the 2 skills. Okay, first step, as with all steps with fractions, you want to convert it into a mixed number. You want to convert it into a mixed number, improper fraction. They're already in mixed numbers, aren't they? Of course they are. So 4 times 3 is 12, plus 2 is 14. 14 over 3 divided by 4 over 3. We already had that one in the last question. Okay, so hopefully we've had enough practice here. We're getting used to that conversion between improper and mixed fractions. Okay, now what we're going to do is we're going to divide the fractions. How do we do that? This is something that people often forget, and there's 2 big misconceptions that come with it. And this is what normally happens. The first thing is they forget that they need to flip the second fraction. We call that the reciprocal when you flip a fraction over. So we have 14 over 3, and we flip the second fraction, so it's 3 over 4. And then we change the sign to a multiplication. Okay, so the way in which we try and memorize it in my classes is keep, flip, change. So keep the first fraction the same, change the second fraction, and keep the first fraction the same, flip the second fraction, and change the sign. The opposite of divide is times. Keep, flip, change, or KFC. Okay, my favorite kind of chicken. So 14 over 3 times 3 over 4. Fine. We want to multiply across. Another thing that students do here is they try and make the denominators the same. That's not necessary for timesing fractions. You just times across. It's so basic. You times the numerators and you times the denominators. That's all you need to do. So you do 14 times 3 over 3 times 4. And that's what we can do. We multiply across and we get 14 times 3 is 42. And 3 times 4 is, of course, 12. Okay, again, mixed number, simplest form. As with last time, I like to divide first, as in I like to simplify the fraction first. So what can we do here? Well, I can see that 2 goes into both of them. And if I did that, I'd get 21 and I'd get 6. Okay, maybe there's a bigger number that goes into it. Maybe you can see it. Maybe you're shouting at the screen. Absolutely, we can divide them both by 6. If I divide them both by 6, that's going to give me the best outcome. It's my highest common factor there. But if you did divide by 2, what you would notice is you can then divide by 3, and it's fine to do it in 2 stages. You just have to simplify twice in that instance. I'm lazy, so I like to just do it in 1 step. 42 divided by 6 is 7, and 12 divided by 6 is 2. That's a nice one for me to convert into a mixed number. 2 goes into 7 3 whole times. Okay, and the remainder is 1. So it's 3 1/2. Okay, so 2 marks available here for this question. And to be honest, it could be 3 as well. It actually entirely depends on the kinds of questions they've asked before. So if it was a 2-mark question, then that implies it was probably a part B that would be a follow-on from what I showed you in question, oops, I went too far, question 4. Okay, so if it was a 2-mark question, then it would be 1 mark for the entire process, which seems a bit harsh, but 1 mark for converting it and multiplying the correct numbers, so that flip. So if we look at this bit here, that would be where I'd get my mark. The second fraction's been flipped, the multiplication is taking place, and that's all good, and then my second mark would come here. If it was a 3-mark question, then it would be 1 mark for converting into improper, and then 1 mark for the flip and the multiplication, and then 1 mark for my answer. Okay. One final point on this, just before I move on. If you are really understanding fractions well, what you might notice is these 3's can cancel out here, and that would be a very good way of approaching the question. Okay, so again, this is for someone that's really sort of comfortable with their cross multiplying and with their simplifying. You can see that these 3's would actually end up cancelling each other out, and you might even see, let's do that in blue actually, blue would be a better colour, wouldn't it? You might even see that 2 is a common factor between 14 and 2. You can divide both of these by 2, so actually 7 over 2. And what happens is when we combine our fraction, we get 7 over 2. Now, if you weren't very happy with that method that I've just shown you, the one in blue that we've just done, don't worry about it at all. The more straightforward method is the one I showed you originally, but that one is a deeper understanding and one that would be quite useful on the higher tier, particularly when you come to working with algebraic fractions. You often want to spot the common factors before you do the multiplication. Okay, so this question, we've got our mixed number here, and you can see there's 3 operations. We've got a subtraction, and we've got, there's not 3 operations, there's 3 terms, and we've got 2 operations, a subtraction and a division. Okay, now the clue here is you've got to work with BIDMAS. Some people think BIDMAS is only reserved for BIDMAS style questions, but it is just the order of operations in maths. So whenever we come across mixed operations, you have to follow the BIDMAS rules. Now, if I quickly write out BIDMAS, we'll see this is the order in which we do things. Now, you always do your brackets first. Most people are comfortable with that. After that comes indices. That sometimes causes problems. Then we have division and multiplication, which are kind of equal to each other. It doesn't matter which order you do them in, but they come together. Then we have addition and subtraction. So, looking at this question, we are going to do our division first, and then we're going to subtract our answer from that first fraction. So I'm going to forget about the 2 2/3 for a second, and I'm going to just I'm going to subtract that answer of whatever it was, but I'm going to do that calculation first. So I'm going to come back to that. So we're going to do 1 3/4 divided by 1 1/8. We're going to get a value for that, and we're going to subtract that from 2 2/3. So let's work our way through here. This is a division which we've looked at before, so let's convert them into improper fractions. You've got 7 over 4. I'm now going a little bit quicker with my conversions, because if we can do them mentally, then that's great. If we know the process, which we've gone over a couple of times, then that's also fine, and we can do it a little bit slower if we want to. Okay, and then the next one is 9 over 8. Oops, divide. Let me rub that out. That's not going to work, is it? Dividing by 9 over 8. Now, what we could do, we could have just jumped straight to a multiplication, but what you're demanding of yourself there is quite a lot from your working memory. So it's better just to write it out in short, sharp steps, and then we can move on to the next bit. So we're going to divide by 9 over 8. That means we flip the 9 over 8. 7 over 4 stays the same, keep. Flip the 9 over 8, 8 over 9. I do apologise for these weird streaky lines that come through every now and then. They do cause a few issues. And then we change the sign, we multiply. So you're multiplying across, you get 56 over 36. Now you could jump straight into trying to subtract that. As I said, we're going to take the answer here and subtract it from 2 2/3 on this side here. You could do that, but it's actually easier to work with simplified fractions because they're smaller numbers, and smaller numbers are easier to work with. Okay, so 56 and 36, well, they could both be halved and you'd have 28 over 18. They could both be halved, you'd have 14 over 9. Okay, now you can also divide both of these by 4. There's lots of ways of thinking about this, but that is it in its simplified form. So if I divided 56 by 4 and if I divided 36 by 4, I'd get 14 over 9. That's an easier one to subtract. Okay, so 14 over 9. Now, obviously, I can't do the subtraction until 2 2/3 has been converted into an improper fraction. So we quickly do that. We get 8 over 3. Subtract 14 over 9. Okay, so 8 over 3, subtract 14 over 9. The first one to change is 8 over 3. I multiply the fraction, both top and bottom, by 3. If I do that, I'm going to end up with the same denominator as the fraction on the right. So I multiply both sides by 3, top and bottom, and I'll get 24 over 9, subtract 14 over 9. Okay, subtraction means the denominators does stay the same in this question. So 24 over 9, subtract 14 over 9. 24 take away 14 is 10 over 9, which gives us 1 and 1/9. For some reason, my 10 over 9 didn't write. Let's go back to that. 10 over 9. No, I'm struggling with that bit. My controls are in the way. 10 over 9. That'll have to do. Okay, so quickly then, 3 marks available. Seems a bit harsh, but this would be right at the end of the foundation paper, question 3 or 4 of the higher paper. 3 marks available, 1 for identifying you do the bid mass first and then trying the right process, so flipping and changing. So we got 1 mark for this area here. Okay, another mark for then subtracting that, and then a final mark for our actual answer there. 3 marks available. Okay, now we're on to the exam style questions. So we're going to use those skills that we talked about, and we're going to run through a few other things just to talk about exam technique. Focusing on this, Ikram, Luke and Noah share £120. Fine. Now, some people like to underline absolutely everything they come across. I don't necessarily believe in that. I like to underline the key bits of information. So Ikram gets 40% of the money. Other people might just underline that because they see a number. I wouldn't necessarily underline that. That's something I'm going to work with. 3/8 of the money goes to Luke, and the rest of the money is given to Noah. The thing I am going to underline, bizarrely, is the rest. So he's getting everything else. How much, what fraction, of the money does Noah receive? The strategy for me here is to work out how much money Noah receives. Noah receives N pounds for Noah, and then put it over 120, because that's the total amount of money. So that's what my strategy is going to be. What I'm going to do is lay it out really logically for the examiner. First thing, Ikram. That's an I, by the way, not a 1. Ikram. So I write an I circle it. This is what I'm going to work out. And I'm going to work out 40%. Very quickly, 100% is equal to £120. 10%. This is just how I like to lay these things out, because then I can really picture it. 10%, I'd get it by dividing 100% by 10. You probably know that you find 10% by dividing by 10, but this is just how I lay it out. So 12. And now we skip up to 40%. Again, quite straightforward. To get to, we multiply our 10% by 4. 12 times 4 is £48. Okay, so Ikram gets £48. That's logical, it makes sense. Ikram is there. Let's move on. Let's check out Luke. Because remember, Noah is going to get everything else. So if I know what Ikram gets, I know what Luke gets, I'll be able to work out what Noah gets pretty easily. 3/8 of 120. Remember what I said. That of means times. 3/8 times 120. Okay, so we're going to do 3/8 times 120. Remember, number divided by denominator times numerator. That's how we want to do this. Okay. In this particular question, it could be a calculator question. It could also not be. There's several ways of doing this. For me, 120 divided by 8. You might want to do. You could do 120 divided by 4, and then 1/8 would be half of that again. So that's quite easy. 120 divided by 8 is 15. That's how it is, because 120 divided by 4 is 30, and an eighth is half of that again. So 1/8 is 15. 120 divided by 8 is 15, times by 3 is 45. So Luke gets £45. No problem there. Luke gets £45. Moving on. One more then. Let's go to young Noah. Noah, he's going to get the rest. So he is getting whatever is left after we have £120 and we take away, notice I'm using brackets here, the 48 and the 45 added together. So I add Luke and Ikram's numbers together, 48 and 45, take that away from 120. So it's going to be 120 subtract 93, which means Noah is going to be getting £27. £27. Remember, what fraction of the money does Noah receive? What fraction? So it's not just does Noah get, how much does Noah get? He gets 27. It's what fraction. So he gets 27 out of 120. That's the fraction he receives. Now, they've not asked me to simplify it, so I actually don't have to. You only have to simplify when you're told to. If I needed to simplify, we could divide everything by 3, and we would get 9 out of 40, which is also fine. You do not need units either, because it's a fraction. Pounds aren't necessary. So either of those answers are great. 3 marks available. Let's run through it. 1 mark for showing a process, either with Ikram or Luke. So let's just say it was for Ikram, showing our process to work it out. Another mark for subtracting the two values from 120 and getting towards that £27. And then 1 mark for actually writing it as a fraction. Remember, you don't have to simplify it unless they ask you to. Okay, we're moving on. There is an outbreak of measles in Cranbrook. That's the town I actually grew up in. Here we have a breakdown of the children that have caught it. So 1/9 are under 5 years old. I'm going to write that as a fraction. It's annoying it's written as in words, isn't it? Let's work with it as a fraction. 4/9 are from 5 to 10 years old, so between the ages of 5 and 10. 48 are over 10 years old. So that's now a number, it's not a fraction. In total, how many children in Cranbrook have got measles? Right, well, we know 48 over 10 have it. So this is actually going to be a reverse fraction question, much like one of the ones in the skills check. Okay, we know that 48 children have it, and we want to know what fraction that is of the total. So what fraction of the children are over 10 years old? That's what we want to work out. And to do that, we want to know what's left to get ourselves to 9/9, because that's a whole, remember. So we're going to subtract these two from 9/9. That's going to tell me what fraction is left for 10-year-olds. And you might have been able to do this in your head. You may well have jumped straight to your answer. Watch this, I'm going to have my brackets, there you go. And you may have been able to tell me straight away that actually 4/9 of the children are over 10 years old. Okay, so 4/9 as well, similar to the second group here, the 5 to 10-year-old group. So I told you this was a reverse fractions question. 48 of the children is 4/9 of the total. That's what we're saying here. It's a reverse fractions question. Now remember what we did, we had our bar model, and I believe I had some technical difficulties with it last time. I couldn't draw my curly brackets. Now you can split it into 9. 9 is becoming to be a little bit annoying though, isn't it? So we're going to also explore how we could do it without the bar, but it does help us think about it. So I'm going to split this to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's 9 equal parts. They don't look equal, but it is 9 equal parts. Okay, and 48 children are represented by 4/9. So here's my 4/9. Let's see if I can draw a curly bracket this time with my computer allowing me. There we go. And that 4/9 represents 48 people. So remember what we did before. Let's see if we can find out what 1 bar represents. This one here. Well, to do that, I've got four boxes representing 48. So to find 1 bar, I divide by 4. 12. Each 9th is worth 12 children. Each 9th is worth 12 children. So that's 12 children. That's 12 children. That's 12 children. You get the idea. And they add up to 48, don't they? If I want to know in total how many children have got measles in Cranbrook, well, there's 9 boxes to represent the total. I know 4 of them. I've got another 4/9 here, 12. These are the 5 to 10-year-olds. And I've also got my under 5s. They're there. Okay. Obviously, hopefully you can see that we've got 9 times 12, lots of children, which is 108. I'll write that in my answer box here. 108. Okay, so tick that off. 1 mark obviously for your answer. It's a 3-mark question though. Where's our process? First thing for identifying the 12 children being 1/9. So identifying 1/9 of, something. You can use a bar, or you could have just divided down. So without using our bar, potentially we might want to consider some working out like this, which will be useful for a question later on. Well, if 48 is represented by 4/9, then what's 1/9 going to be? We have to divide that by 4. 1/9 is dividing by 4 from 4/9. 1/9 is going to be 12. Okay, and then we can scale up. What would 9/9 be? Similar to what I was doing with percentages in the last one, we're scaling up and down by the same values, aren't we? So we're just multiplying, times it by 9. That's going to be 108. Okay, so there we have it. And as I said, so let me just quickly run through those marks again. 1 mark for the answer, 1 mark for finding 1/12, and 1 mark for multiplying it by 9, and showing that you know that you have 9 lots of it. Okie dokie. This one, actually another reverse percentages question, it turns out. We've got Alfie, we've got Bilal, we've got Cham. And they are sharing a sum of money. We don't actually know how much the money is to start with, but we do know that Alfie receives £1.50. Okay, and Alfie also gets 3/8 of the money. So now I'm going to try it without the bar model, because there is a more fiddly question, shall we say, where the bar would not be as appropriate. So let's see if we can get that done. So let's start with Alfie. Mark that for the examiner. We're going to start with Alfie. Alfie receives £1.50, and he also gets 3/8 of the money. That 3/8 is equivalent to £1.50. Notice how I don't use an equal sign. You could get away with using an equal sign, you absolutely could, but 3/8 isn't actually technically equal to it. So I like to use the arrow just to kind of show that they're linked, but they're not the same thing. 3/8 is the fraction that he's got, and that fraction is worth £1.50. Okay, so next step, well, what would 1/8 be worth? 1/8 would be worth 50p. Why? Because I have to divide by 3 on this side to get from 3/8 to 1/8, and I have to do the same on this side, just like that, scaling up with percentages. Okay, so that's where we've got to, and that's going to be incredibly useful, because now I can think about the total amount. And there's a few things you can do here that will work. One, you could jump straight to Bilal's amount of money. If you know that 1/4, and I am going to use equal signs now, is equal to 2/8, then you'll be able to work this out very quickly. Bilal gets 2/8, doesn't he? So 1/8 is 50p. Bilal gets 2/8. We're scaling up by doubling it. He gets £1. That would be one way of working this out. Okay, and in the interest of time, I'm going to leave it with just that one way. You could, I'm going to say quite quickly whilst I'm just getting my green pen ready, you could find the total of 8/8 and then find 1/4 of it. That would also get you Bilal's money. So 1 mark for demonstrating that, 1/8. Okay, and the next mark for identifying that you're going to scale up to 2/8, and then obviously again for your answer of £1. Do try to write your answers in the answer box where you can. Sometimes you can't, they don't give you one, but where you can, do try to do that so the examiner knows exactly where to look for your answers. Okay, moving on. Mary is walking from Collierswood to Putney and comes across this sign. Fine. We've got Collierswood off to the left, we've got Putney off to the right, with the various distances given to us, and we've also got Wimbledon Park. So a third place. She's not walking there, but it's also on our signpost. Maybe we will need to use it. How far is the distance between Collier's Wood and Putney? Well, if Collier's Wood is all the way over here on the left, and that's 2¼ miles away, and then we're here, and then we're going to go 3 2/3 kilometers in this direction, what you're effectively doing is adding those two journeys together. This is 2¼ plus 3 2/3. Okay, so we've done quite a bit of work on the skills check and on adding fractions and things. So we're going to quickly go through that now. 2¼ is 9/4. We're going to add to that 9/11/3. Now we're going to convert them into the same denominator. That denominator, and normally I'd like to work downwards with this question, but it's not giving me enough space, and that's fine. So we have to deal with what we're dealt. So we're going to work across instead, but it's all still equivalent to each other. So 9/4, I'm going to convert it to 12ths. So my denominator is 12, and same for 11/3. The denominator, the common denominator will be 12. To do that, I timesed it by 3, the 4. So I'm going to times the 9 by 3 as well. There's 27. I'm going to add to that 44/12. Put those together, and we're going to get 61/71/12. Remember, we don't add the denominators together, we do add the numerators. Okay, I don't have to put that into mixed form unless I'm asked to. You will get full marks if you are not asked to do it. You don't have to do it. Okay, so I'm going to leave it as 71/12. How much further is Putney than Wimbledon Park? I'm going to do this one in blue just so we know we're doing question 2 there. Well, Putney is 3 2/3. And Wimbledon Park, so we're here and we're trying to get to Putney over here. Ooh, what's happened there? So we're here and we're trying to get to Putney over there. Wimbledon Park is 1 2/5 away, so it's not as long. So 1 2/5. How much further is Putney than Wimbledon Park? Well, all we need to do here is work out that distance, work out that gap that we're looking for. And that gap is here to here. Difference is a subtraction. Okay, so now we're going back to using our red pen. 3 2/3 subtracted by 1 2/5. That's what we're looking to do in this question. Okay, we're going to be converting them. So we're going to have 11/3, which we had in the first question, and we're subtracting from that 7/5. 15ths is going to be the easiest thing to work with here. So 55/15. Notice I'm moving a little bit quicker through this question now because we've done the skill of adding and subtracting quite a bit. And I'm going to be subtracting from that 21/15. Okay, that's going to be 54/34/15. Again, I don't need to simplify. I don't need to. I can't simplify anyway, but I don't have to, and I don't need to write it as a mixed number. Okay, so that's that question done. Just quickly for the marks. Notice you're getting less marks here, but even though the operations are the same. So as in 3 marks for the first question, because you've demonstrated you know how to do that, the second question is only worth 2 marks. So first question, you get a mark for converting to improper fractions. You won't get that mark in the second question. Next one, denominator's the same, that's worth 1 mark, and then your answer. So in this question, they're expecting you to make the improper fractions the same, or sorry, to make it into improper fractions. So then what you're looking at is denominator's the same, and your answer there, 5 marks. Okay, right, I need to get a wiggle on, so let's make sure we're doing this. This one is the question that wouldn't work very well for a bar model. A fish tank is 4/5 full. 22 litres are taken from the tank. The tank is now 1/4 full. How many litres does the tank hold when full? We're going to do a subtraction here. We're taking away 22 litres. To find out what that is as a fraction, I'm actually going to do 4/5 subtract 1/4. That will tell me how much of a fraction I've lost, and that fraction will be equal to the 22 litres. Okay, so we've done this adding and subtracting of fractions before. So very quickly, it's going to be 16/20 subtract 5/20, which gives us 11/20. When I removed 22 litres, I removed 11/20 of the water. Okay, so remember what we did. If 11/20 is worth 22 litres, what's 1/20 worth? We used the bar model before, but I do not want to draw a bar and split it into 20 pieces. So this method might work a little better for us when we've got a bigger thing to deal with. Divide by 11. Divide by 11, we get 2. Okay, how many litres does it hold when full? That means I'm going for the full 20/20, which is going to be times by 20, 40 litres. 40 litres when full. Okay, so 1 mark for our answer, obviously, 1 mark for our subtraction, and 1 mark for finding that 1/20. Remember, that's really crucial to all of these questions, was finding that 1/20. Okay, this question, not too bad, I don't think. The supermarket gives £1,200 every month to local charity. The amount given to each charity is in proportion to the number of votes they get. Proportion. In February, there were 400 votes altogether. Given as follows: the Air Ambulance got 190 votes, Heart Disease Foundation 120 votes, Children and Youth Services 90 votes. How much did each of the charities receive in February? Okay, so in 1 month. Well, for Air Ambulance, I note down AA, circle it. I'm going to do 190 out of 400, and I'm going to times that by 1,200. Okay, you can simplify this a little bit, but actually I'm not going to simplify it because I know how many 400s go into 1,200, 3 of them. So that's actually not too bad. And then I'll times my 190 by 3. Remember, divide by the denominator, then times by your numerator. So 1,200 divided by 400 times by 190. Okay, that's going to equal 3 times 190, which is going to give me £570. Okay, that's how much they get. We're doing something similar then for heart disease. Heart disease is 120 over 400 times by 1,200, which divide by 400 is 3 times by 120 is 360. So that's my answer there. I've only had to demonstrate it once for Air Ambulance. And then finally, Children and Youth Services, 90 over 400 times by 1,200. Same idea. 1,200 divided by 400 is 3 times by 90 is £270. They get the least. And there are our answers. Okay, moving on. Question 7. With this one, we've got a number of things going on here. We want to know if he's correct, so we have to write a statement, either yes or no, but we need to have the working out that shows it. So he has 24 feet of ribbon, and he cuts strips that are each 2 1/5 feet in length. Okay, that's important. I can cut 11 of these strips from the ribbon. The quickest and easiest way to do it would be to say, well, he's going to have each one as 2 1/5, and if he has 11 of them, how much ribbon will he actually need? So let's just times it. If it's greater than 24, he doesn't have enough ribbon. So convert it into an improper fraction. We've done this to death. And we multiply that by 11. Remember what I said with timesing of fractions and things? You can put a 1 underneath it. Sometimes it's not easy just to divide the denominator times by the numerator. This is one of those instances. Here, you're going to get 121 over 5. Okay, now the question is, how many 5s go into 121? How many 5s go into 121? The best way to do it is to divide by 10 and then double it. That's the quickest way to divide by 5. Divide by 10 and then double it. Okay, so if we divide by 10, you'd have 12.1. If you double it, you get 24.2. Now, if we're not sure about that, how many 5s go into 121? 24 5s go into 21, and this would be a calculated question in terms of thinking about that, and you will have 1/5 left over. Does he have enough? Is he correct? No, he's not. We need that statement. It doesn't have to be much, but we have to say no, because 24 and 1/5 is greater than the 24 feet of ribbon that he has. Okay, linear sequences. What you need to do for this question, you need to find out the difference between each of the terms. Okay, so to find the difference, you do 2 2/3 minus 1 1/2. Now, in the interest of time here, because I am conscious of it, and we've done these questions quite a lot, what I'm going to do is I'm going to tell you that after you do everything, you get 7/6. That's the difference. And if I was to check it with any of these other ones, it would all be 7/6. Now for nth term rule, this is really important. We're now linking a little bit of algebra here. For nth term rule, you always write that difference, what it's going up in, and you multiply it by n, because it's going up in that numbers times table, so 7/6 times table if you like. Now for me, and what works well for my students, is the next bit that you add to your nth term rule is always what we call a 0 term, whatever this number is here. If that's the first term, second term, third term, fourth term, the 0 term will be this number here. How do we find it? Well, you're going to subtract 7/6 from 1 1/2. So 1 1/2 subtract 7/6. Okay, and when you do that, you're going to obviously have here 3/2 subtract 7/6, which is multiplying the first fraction by 3 top and bottom, 9/6, subtract 7/6 is 2/6, which is a third. You don't need to simplify it because they haven't asked you to, but it's good practice for this question, so why not? And it looks a bit tidier, a bit nicer. So it's positive, I add on the third. So for nth term rule, you have to find the 0 term, and then you just add that to your, or subtract it if it's negative, to your n term. Okay, so find the difference, multiply it by n. That gives you 7/6, n, and then add on or subtract, if it's negative, the 0 term. 3 marks available there. 1 for finding the difference, 7/6, or trying to find the difference. Then for actually having 7/6 n, and then for finding the 1/3 n, using that process to find the 1/3. Okay. Final one, higher tier only. This is recurring decimals. So recurring decimals, two fractions. Not too difficult, but if you've done the skill. Now, this is solely for higher, that you are not needed to do this on the foundation, and it's quite a high level topic. The first thing we want to do is convert this into a fraction, okay? X is equal to 0.95, both recurring. We are setting it equal to X. We're going to get rid of that recurring part. Now, what that means is you want to have an X term that has 95 in it after the decimal as well. So some of you might think to times it by 10 and you'd have 9.59. That's not going to be the one you want. Let's just quickly write that down, 9.59. That's not going to work because they need to be exactly the same. So 10x is no use to me. 100x, let's think about that. That's going to be 95.95 recurring. The two numbers after the decimal are in exactly the same order as for x. That means I can cancel these out. If I do 100x, subtract x, I'll be able to cancel them out and I'll no longer have a recurring part of my fraction, of my decimal, sorry. So 99x is 100 take away 1, and the recurring parts cancel out. I'm left with 95. So what's x? Dividing by 99. If you know this skill, this should now be quite nice and straightforward from you if you've done this before. 95 over 99, and then you're going to multiply it by 3/5. So 3 and 1/5, not 3/5. So 3 and 1/5. 3 and 1/5 is 16 over 5 multiplied by 95 over 99. Not a nice question to do a multiplication for. I would advise that trick I showed you earlier very briefly to divide out the things that you have in common with these two. The 5 and 95 can be divided out. Divide out by 5 on that and divide this by 5, it's 19. Okay, 19 times 16 is actually quite easy because 20 times 16 is 320. Subtract a 16 and you'll get to where you want to be, 304 over 99. Now you might need to do some side bits to work it out, to do the multiplication. That's fine if you do. And that is actually simplified, but we can also write it as a mixed fraction if we need to. It's going to be 399 times by 3, that's 297 because of 100 times 3. And then we need 7 more. 7's a prime number. It doesn't go into 99. We can't simplify. That's our answer. Okay, that's a tough one, and that's just for higher. That does bring us to an end once we do our marks. So just quickly setting this up and working our way through, showing this entire process is worth 1 mark. Getting a value of 95 over 99 is 1 mark. Doing the multiplication and getting 304 over 99, doing the multiplication is 1 mark with our improper fraction of 16 over 5, and then final mark for getting either 304 over 99 or 3 and 7 99ths. And that does draw an end to the demonstration. I hope you have found it useful. I hope there's been some takeaways for you that you will be able to use in your upcoming exams.